Oh, 9.4. Ellipses. Definition. Okay. Hopefully you kind of looked at this just a little bit. All right, because otherwise I'm not waiting for forever for you to write all this and draw all this. So leave yourself some space, and if you want to go back to it, okay? Ellipse. Definition: the set of all points in a plane, such that the sum of the distances from two fixed points is constant. These 2 points are called the foci, which is plural for focus. Okay? So now you have 2 foci. Focuses. Foci? Foci. Okay? You have 2. Typically, they are within a little bit. Okay? Where am I at? Yeah, they're inside a little bit. See where it says F right here? That stands for focus, not what you think it stands for. Okay? It's your focus.
It's not fire truck?
What? No, it's not a fire truck.
Okay.
Alright? These are your foci. Okay? Every ellipse has 2 axes of symmetry, right? Because an ellipse is just a fancy word for basically an oval. Okay? So you have 2 axes of symmetry. You have one running long ways and one running short ways. And that goes whether you're stretched out horizontally on the xy coordinate or whether you're stretched vertically on the xy coordinate. Alright? They're called the major and the minor axis. That's right here. Alright, major axis, minor axis. The axes are perpendicular, which means they make a what?
Right angle.
Right angles. At the center of the ellipse. So here's the minor, here's the major, here's the center. That's where they intersect. That's where they're perpendicular. The shorter one. Whichever way it's oriented, the minor is always the shorter one, the major is always the longest one. Okay? Make sense? Alright, the foci are always on the major axis. Because your vertices are always on the major axis. And your foci are just inside, just a little bit from your vertices. Okay? The endpoints, I just said this, the endpoints of the major axis are the vertices of the ellipse. And the endpoints of the minor axis are the co-vertices of the ellipse. Alright? So, more so than any other conic, you got a lot of stuff going on here. Okay? Even with hyperbolas, there's not as much going on as there are with ellipses. You got a lot of parts going. Okay? Your vertices are the endpoints of your major axis. Here and here, or if it's stretched vertically, here and down here. Your co-vertices are the minor axis, the shorter way. Here and here, or there and there. Alright, obviously you got your center points. And then you have your 2 axes of symmetry. One running down the middle of one long way, one running short way. They meet at the center. Okay. Any questions on that?
It's not always going to be lined up with the XY.
Correct. Eventually we're going to get off being centered at the origin. But not for just the first couple. Okay? Everybody good? Alright. We're going to do some bouncing back and forth here, so stay with me, alright? Alright, standard form. If you are centered at, this is whenever you're centered at the origin. See that? And specific to this. Your standard form is x squared plus over a squared plus y squared over b squared equals 1. Okay? X squared over a squared plus y squared over b squared equals 1. Alright, I'm going to stick with this column. Alright, this first column here. If that's the case, then your orientation for this guy is horizontal. We'll talk about how you tell which one is which in a minute. Okay? Your foci are at points c comma 0 and negative c comma 0. We'll get to how you figure that out. Okay? The length of the major axis is 2a units. The length of the minor axis is 2b units. Okay? Everybody good? Now, let's flip to the other side. Alright? Your other side is whenever you're orientated vertically. That standard form is y squared over a squared plus x squared over b squared equals 1. Okay? Different from your horizontal orientation because, number one, y squared goes first. Okay? Your foci, this time your C's are your y-coordinates. Okay? Because think about how it's orientated. It's orientated up and down, which means your vertices are here and here, which means your co-vertices are up a little bit and down a little bit. So your y changes, yeah? Very good.
Wait, what are your C's?
We'll get there.
Okay.
But just know that your foci are, right?
Okay.
Okay? The length of the major axis, and this is more important than you guys realize. The length of the major axis is 2A units, the length of the minor axis is 2B units still. Okay? Which means the way you tell which way an ellipse is orientated is the bigger number in the equation. Because whatever one has the bigger denominator is always going to be the major axis. A is always with the major, B is always with the minor. Okay? See that? A is with the major. So this one's orientated horizontally by your x's. B is your minor one. Same thing over here. Okay? Everybody good on all that stuff? Okay, I'm going to back up just real quick just to kind of relay this. The stuff that you didn't see. Okay? Now, look at, everybody just focus on the horizontal one for now, okay? We'll make this make sense. This is a vertex, and over here is a vertex, right? See that? Your endpoints on your major axis. The foci are in just a little bit, okay? The C comma 0 and negative C comma 0. Okay? See that? Okay. Now, the length of A, and I think this is at the bottom of that next slide, but I'll get to it. The length of C, okay, what C is the distance from the center of the ellipse to the focus, either direction. Okay, see that? Okay, this is a good slide to have. Just, I know it's going to be a pain to write it. Your B is from your center to one of your co-vertices. All right, see that? Center to covert. A, this A we've been talking about, or at least, you know, it's the length of the major axis, but just A is the distance between your focus and your co-vertice, like that, from here to there. All right, and all that holds true on a vertical one. It's just flipped, right? It's just rotated on how it's orientated. Okay, so between the points of the center to your focus to your co-vertex, you make a what? You make a triangle. Specifically, you make a right triangle. All right, which leads into this. The values of the equation of A, B, and C are related to the equation C squared equals A squared minus B squared. Not a typo. Okay, not a typo. C squared equals A squared minus B squared. All right. A couple other bullets here. The distance from a focus to either co-vertex is A units. I just mentioned that. And the sum of the distances from the foci to any point on the ellipse, or the constant sum, must be greater than the distance between the foci. Write an equation for an ellipse with vertices at 0, 9 and 0, negative 9. Okay? And foci at 0, 7 and 0, negative 7. Alright? Now, the very first thing, like with your parabolas, that I always do is just do a quick etch-a-sketch of it. Alright? With the given information. So I make a little cute little axis right there. Okay, and I know my vertices are at 0, 9, which is about here, and 0, negative 9.
It's vertical.
Very good. Okay? So since you know your vertices are lying on the same vertical line, it means you're orientated vertically. Okay? Make sense?
Yep.
Great. You are told that foci, so let's label even these. So green are your vertices, if I could draw an E today. There we go. Okay? And your foci are at 0, 7 and 0, negative 7, right there. Okay? Everybody good? So the first thing from there you always do. This is basically a three-step process. All right. Number one, you always find your center. Okay. And your center in this case is what? 0, 0. Okay. You're at -9, 0, or sorry, 0, 9 and 0, -9. Midpoint between those two, the origin. Everybody good on that? Won't always be the case, but for now it will. Everybody good there? All right, number 2. Since you know your vertices, and you know it's orientated vertically because of that, that means you can figure out the length of your major axis, which means you can figure out the length of A, or the value of A. Since your major axis is 2A units, okay, from that last box. All right, everybody remember that? Okay. So you figure out the distance between 0, 9 and 0, -9. So let me get this figured out here. I wrote it down properly. So find A is step 2. You know your vertex is at 0, 9, and 0, -9. So then you know from that your major axis is how many units? 18. Everybody good?
So A is 9?
So A is 9. Because the major axis is 2A units long. So 2A is 18, which means A is 9. Okay.
What did you do with those numbers?
What numbers?
Like the major?
Yeah, the length between your two vertices.
Oh.
Okay. 9 units up, 9 units down. Okay. Everybody good? Everybody's still good. Okay, great. Now, you have your center, you have your A. The only thing you are missing is B, which is which you get from your minor axis, right? Which you get from your covertices. But you don't know your covertices. That's the issue. You do know your foci, though, right, Mitchell?
Well, I was going to wonder if you did that thing where it said like x2 over a2 and y2 over b2.
You don't know another point on the ellipse, though. Right. So now you got to figure. Yeah, you use your foci, okay, to figure out B. Now, this is the part where this gets tricky because this is the new stuff. All right. Your foci, remember, is the distance from 0, or C. Let me back up. C is the distance from your center to your foci.
So A is 7?
So C is 7.
Oh, that's not nice.
Okay? Yeah. All right, so step 3, you find B. All right? C is 7 because, like I said, the new part you got to kind of remember for this is that the distance from your center to your foci is C.
Oh.
Okay? So now you put it into your C squared equals A squared minus B squared. So C squared equals A squared. I don't know why I put 7 there, just go with it for a little bit. Minus B squared. So you get 49 equals 81 minus B squared. So B squared equals what?
Negative 32 or it's just 32?
Just 32. Because negative B squared equals negative 32. Right? See that?
Yeah.
Subtracting, then multiply negatives. So B squared equals 32. Okay. And you don't need B itself to write the equation. You need B squared. Okay?
So what all do you leave in the equation?
Here's what I'm getting there. Okay? Everybody get it. It's okay. Last step, write the equation itself. All right? Since you're orientated vertically, your A always goes with your major, so that means that 81, because it's going to be A squared, right? So that means 81 goes underneath your Y. Plus X squared over 32 equals 1. And that's the equation of the ellipse. Origin. Okay. Let me pause. Okay, this is your table of stuff for your ellipses that are centered at HK. So you're not centered at your origin anymore. Okay? Now, the ones, that box a couple slides ago where you were centered at your origin, that box, I give you nothing. Okay? When your ellipse is centered at your origin, I give you nothing. Okay? When your ellipse is not centered at your origin, oh, come on. There we go. I give you those three. That was a beautiful brace. Okay? I give you those three. And those three do get labeled. Okay? So you know which one is your foci, which one's your vertice, which one's your covertice. The only thing you don't know is whether it's horizontal or vertical. Okay? And you figure that out the exact same way. Okay, as you did with like your circles. Or not your circles, your parabolas. Okay, when you move your foci, remember moving your foci in a little bit from there so you're on the H this way. Okay? Or if you're moving them up and down from your vertice vertical, that's why these are C's are where they're supposed to be. Okay? It's all about the relationship of those points. Okay, once you get that figured out, that very first slide we talked about, all this stuff starts clicking. Okay, once you start putting all the pieces in place. It's kind of like a big puzzle. Okay? So when you're not centered at 0, 0, you get the foci, the vertices, and the covertices formulas on how to figure those out. You don't get the standard form of it, you don't get orientation, but you get all this. Okay? Now, it's looking, hopefully it's starting to look somewhat strikingly similar, right? It's kind of a combination of circles and, and not what you know ellipses. Okay? You're centered at HK. You're always centered at HK. And your standard form is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Your numerators are the same as your circles. Your denominators now have those axes in them. And you equal 1 with a plus in the middle. Flip it for vertically. Okay? Now, your foci, your vertices, your covertices, they all have the same relationship between A, B, and C that the ones that center at the origin do. The only difference is you're not centered at the origin anymore. Okay? So now you have to move them with your center point. So now for your foci on a horizontal, it's H plus or minus C and then K as a coordinate. So you have two of them, right? One when it's H plus C, one when it's H minus C. Same with your vertices. H plus A, H minus A. Because of your distances. Okay? Co-vertices, K plus B, K minus B, because you're going the opposite way. You're moving up and down on those. And then obviously the same ones for when you're vertical, except you flip them. Okay? It's a lot of parts. Alright, I get that. It is a lot of parts. Alright, that's why you get some of the formulas too.
Norman, can
Yes.
you technically use these with the center being the origin too? I know it's okay, because the zeros were there.
So, write an equation for the ellipse with vertices at negative 3, 8 and 9, 8. Co-vertices at 3, 12 and 3, 4. Okay, so once again, I always do my etch-a-sketch of it. And my vertices are at negative 3, 8 and 9, 8. And my vertices, I'm going to have to move this down just a little bit.
Wait, isn't that horizontal?
And my co-vertices are 3, 12 and 3, 4. So this one's orientated how? Horizontally. See that?
Why did we just write? Oh, I thought that was vertical, and I was like, what are you two talking about?
My bad. Okay? Which makes this actually be easier. Okay? It really does. If you're given vertices, co-vertices, these aren't terrible. Okay? Because you just have to remember the parts and what they mean and where they're located. Alright? You need 3 things to write the equation of an ellipse. You need your center, you need A, you need B. Okay? Those are the 3 things. Now, the center you get between your vertice points. So you find the midpoint. Okay? So step 1, you do center, which is wonderful. So you run it through your program, you run the midpoint between negative 3/8 and 9/8. Okay? Which is going to tell you that the midpoint is 3/8. Okay? So your center is at 3/8.
Isn't it easier if you just look at the constants on both sides of the
But what if I throw fractions at you? Okay.
You
Yeah.
wouldn't do that.
I would. Once again, I don't know, understand. It's we're
Would they still be constant though? One of them like would still be
yes,
like-
yeah. It's one of them would still,
So it still is.
yeah. But it would still play a trick on your mind. It's almost May. You guys should figure out I'm not a nice person by now. I mean, seriously. Ha! Number 2. Find your major axis. All right. So your major axis is your length of your major axis is the distance between your vertices. Okay. So you can do that 2 ways. You can do distance formula between these two, or you can just do 9. Do the difference between the x coordinates. So 9 here minus negative 3. All right, which gives you 12. So then A equals what? 6, because 2A is 12, right? Everybody good? And since you're given your co-vertices, you can do the same thing with your minor axis, which will be 4, right? So 12 minus 8, or 12 minus 4, which is 8, getting ahead of myself. So B equals 4. Okay? Now you got your parts. You got your center, you got your major, you got your minor. Okay? Now, this is orientated which direction? Horizontal. So when you write your equation, that means which one goes first? X. So X, its coordinate is 3, so X minus 3, quantity squared, over, and since it's orientated that way, that means the major axis goes with it, so that'd be A. A is 6, so A squared is 36, plus y minus 8, quantity squared, over your minus B squared, which is 16, equals 1. Alrighty. Quiet!
Wait, I think I know how to do it.
Alright, this is a basic type of problem. This is the third type. It's not bad. Group your x's, group your y's. We're going to set up completing the square. Alright, so 25 x squared plus 250x plus 9y squared minus 36y equals a negative 436. Ew. I didn't leave space this time because what do I have to do next? You got to factor out some GCFs, okay? Because in order to complete the square, the number in front of the x squared or y squared terms have to be 1. All right, so you take out that 25 from the x's terms. So you have 25 times x squared plus, what is that, 10? I can't believe I just asked that question. That was really dumb on my part. That was really bad. I need a nap. Plus, and it's not even 2 o'clock yet. Plus 9, y squared, let me hope I don't screw this one up, 4. Yes! Leave some space. Equals a negative 436. Okay? Now, here's what I do on ellipses more so than anything else. Like, I don't do this on when I complete the square for vertex form. I don't do it for circles, but I do it for ellipses and I do it for hyperbolas. Okay? And I can do this and make it look really pretty because I have all these different colors. You guys, if you want to use colored pens and you like this idea, do so. Okay? What I do, once I leave the space, I highlight under here, and I highlight under here. Alright? And I highlight the same thing here, and here. Okay? Now, whenever I fill in my x trinomial, I got to multiply it by what? 25. Okay, so I'm even going to move these over just a little bit. So I need to do plus 25 times whatever goes in there. I'm running out of space, so I'm going to makeshift this a little bit. When I complete the square of my y, I need to multiply it by what? 9. Okay? And you add it to the right side because unlike parabolas with vertex form, you're working both sides of your equations, yes? Okay, makes sense? Okay, complete the square on these two, and usually those will end up being pretty tamed. Okay? First one, you divide by 2, you get 5, you square it, you get 25. Whoops, I went to the wrong spot. I need a nap. Oh man, the struggles. Okay, so plus 25. The second one, you end up adding a plus 4. Divide by negative 2, square. Okay, so in your green spot goes a 25, and your pink spot goes a 4. Okay, everybody good so far? Factor your trinomials. Alright, so 25, x plus 5, quantity squared, plus 9, y minus 2, quantity squared, equals. And negative 436 plus 25 times 25 plus 9 times 4 ends up being what? 225. Okay? Now, something you haven't noticed, maybe you have. Every single equation of an ellipse equals what? 1. So you divide both sides by 225. That side, and that one. Okay. The right side reduces to 1, as it should. Okay, see that? The left side, 25 goes into 225 how many times? 9.
Oh.
9 goes into 225 how many times? 25.
Are you kidding me? I should have just kept going. I thought